Hey guys, here talking about 2.2b. This is going to be a two-part video, so I'll just try to do a shorter one here and then just give you part of the assignment, and then we'll do the other video later and you'll have the other part of the assignment, and then kind of just do that all at one time. Just talk about writing linear equations, finding linear equations, things like that. Linear equations make lines, right, because of their constant change. That the way that the points change is constant. And so, of course, that constant change is called our slope, and we use the letter m to represent the slope. And so we have delta y over delta x. Delta is just math or a science symbol for change, and so we talk about the change in the y values over the change in the x values. So finding the slope of a line that's through 2 points doesn't need to be more complicated than it is. So if I look at the change in the y value, so how much am I changing as I go from one point to the next? So we see that to go from 6 to 4, we'd have to go down 2, and then over the change in the x values. So if I'm going from, so just make sure you're going in the same direction. I went from the point here written on the left to the point written on the right. So here, as I go from x to x, I'd have to be adding 3, right? And so positive 3. So the slope would be negative 2 over 3, or sometimes just written as negative 2/3 with the negative off to the side. It's kind of my general habit when I write a fraction, negative fraction, just always put the negative on the top of the fraction, but it's also acceptable to put it on the side. Of course, there is a slope formula, and that just means you gotta remember the formula: y2 minus y1 over x2 minus x1. Again, it's just the change in the x's, or change in the y's over the change in the x's. So if you're going to use the formula, then you got to go through and label. This is my x1, my y1, my x2, and my y2. So using the formula, we would say that's y2 is 9, so minus y1, which is 2, and then x2 is 3 minus x1, which is 5. So I get 7 over negative 2. Again, nothing wrong with it that way. Definitely never use decimals or mixed numbers when we're talking about slope. It's always leave it as an improper fraction, because the numerator stands for something and the denominator stands for something, so we don't want to turn it into a decimal or a mixed number. This is my rise and this is my run. Those are really important words to kind of keep in mind too when you're talking about slope. So rise over run, but nothing new. So what's a line with positive slope look like? What's a line with negative slope look like? What's a line with zero slope look like? What's a line with undefined slope look like? So positive slope just means that it's rising from, as we read from left to right. So this could be a line with positive slope. This is also a line with positive slope, just more slopey, right? Something that's negative slope is going to decline from left to right. So something like this line here would have negative slope, or again, you can have a steeper negative slope. Those both have negative slope. They both go down as we go to the right. A slope of 0. So if you think about what that means that the rise would be 0 over some sort of run. So this line does not rise. What does a line that doesn't rise look like? So that's a horizontal line. All right, so horizontal lines have slope of 0. What's a line with undefined slope look like? So undefined values are when we divide by 0. So the denominator would be 0, which would mean that our run is 0. So what's a line that doesn't run look like? That means that line is vertical. So vertical lines have undefined slope. Horizontal lines have 0 slope. So here's a little statement about if you ignore the sign and just look at the numbers, the bigger number means a steeper line. So this slope maybe is like 1 over 2, okay? And then maybe this slope is, 4. So it's a bigger slope value, so it's a steeper line than this one. Maybe this orange line has a slope of negative 1 over 3. And then the slope of the red line might be like negative 3 over 1, or just negative 3. So again, just ignoring the signs, right, that 3 is a bigger number than 1/3. So this line would have a steeper slope than this line. Of course, these lines here have the same slope because they're both horizontal, and these lines here have the same slope because they're both parallel, or vertical. So I can't have a flatter or more horizontal line. I can't have a more vertical line. There's either vertical or now not. So comparing two lines, comparing their slopes, right? So if one had a slope of 1/4 and the other one had a slope of 4, how could we compare those? You just say that the line with slope of 4 is steeper than the line with a slope of 1/4. So this line would be rising 4 for every one of its runs. This line's only rising 1 when it runs 4 units. So there, talking about y-intercept. Of course, definition, the y-intercept is the location on the y-axis where the line crosses, right? So we're just looking for that point there, right? Location on the y-axis where the line is crossing. So here we're seeing that line is crossing at 0, what's that, negative 3. So a big thing about y-intercepts is that x is always 0. That's actually a really important thing just to know when you talk about a y-intercept. So later on when we're trying to find y-intercepts and x-intercepts and stuff like that, you just need to know when you're trying to find a y-intercept that means the x value for that problem is 0. And the y value would be whatever the y-intercept is. So again, a really important thing that you guys should just know. Like, it's one of those really important math facts that will help you do things. Just to have that on recall. So the slope of this line, so we need to have 2 good points to look at. So if I use that y-intercept, that 0, negative 3, and then let's see where else I have a good point. Looks like I got one right there. I've got another one over here. A couple of good points I could use. I'll take one that's a little bit further away. Looks like there's a good point right there. So slope is rise over run. So how much do I need to rise to go from one point to left? You always go from left to right. So the leftist point, start on that one. So I'm rising 4, and then I'm running 2. Okay. So again, when you're looking at a graph of a line trying to find its slope, always pick 2 points. But when you're trying to find that slope, go from the left point to the right point. Okay, just like you're reading. So my rise was 4. So we say m equals, the rise was 4. The run was 2. Of course, that reduces down to just 2. Good old slope-intercept form. Definitely something you guys should all know. Is, of course, y equals mx plus b. And of course, that's where the slope is m and b is that y-intercept. So putting those values. So we would say that y equals something times x. So that's slope being 2. And then the y-intercept was negative 3. So I'd have 2x minus 3 would be the equation of that line in slope-intercept form. So again, what that tells me here is that the line will cross the y-axis at negative 3, and that it will have a rise of 2 compared to its run of 1. So rising 2, running 1, rising 2, running 1, rising 2, running 1. It's that constant change between the points. So it's going to do that same thing here with these 2 lines. So, and usually the easiest thing I want to find out is what's b. And then, after that, I want to find out what m is. Then we're going to put it into slope-intercept form. So find that y-intercept, not the x-intercept, so starting there. So it looks like the y-intercept is at 0, 1. And then the slope, so I'm going to take that y-intercept, find another good point. Looks like there's one right here. And so what's my rise, what's my run? So again, start on that left point, so I have to rise 1. And then I'm running 3. So I'm rising 1. And I'm running 3. So there's my slope. So then y equals 1/3 x plus 1. So taking my slope, putting that there, taking my y-intercept, putting that there. And it's positive 1, so I'm writing plus 1, right? So there's my equation. Let you guys write the equation for the second one here into the Edpuzzle. Let's see. They did here, y and x are still letters. Important thing I told you to remember about y-intercepts is that the x has to be 0 in order for it to be a y-intercept. So the x-coordinate has to be 0. Okay, so the point slope form is just a different way of writing an equation of a line. Again, the slope being represented by m here. So that's that, and then we just have kind of like a random point on the line. So we have our x1 value, and then we have our y1 value here. So it's a little bit more of a flexible form of the equation of a line because we don't have to have that specific y-intercept value. It can have any point on the line and start to be able to graph it or know something about it. So again, just a more flexible version of the equation of a line. So we're going to take some information, we're going to write an equation of a line in point slope form, and then we're going to transfer that into slope-intercept form, and then they're giving us some information about that line. So we know that the slope is 4, and we know that the point on the line is 2 5s, right? So in order to write the equation in point slope form, I would need a point and the slope, right, over here, okay? Rather than if I want slope-intercept form, I have to have the slope and then the y-intercept, which we don't have. So we would not be able to do this yet with the information we have. So, but we can take this and transform it into that. So sometimes it's helpful, just label those. Again, that's your x1 and your y1. It's not the x and the y. These things here that are red are going to stay letters, right? Y and x are going to stay letters when we write it, just like whereas y1, m, and x1 are all going to become numbers when we plug stuff in. So y minus, so y1, which was 5, equals m, which was 2, I think? 4. So 4 times x minus, and then of course x1 is 2. And so the only thing that you do when you're writing an equation in point slope form is to simplify any signs. So like if this had been a negative 2 instead of a positive 2, that we'd have x minus negative 2 here. And so then there's that kind of sign switch. So we see that again, with things inside the parentheses are lying to us about their sign, that the value we have is negative 2, but we end up writing plus 2. Same thing would happen here. If that had been a negative 5, this would say plus 5. But because of these minuses here, x minus negative 2 would become x plus 2, right? Y minus 5. So, there's actually a positive 5 that we're plugging in here. It's actually a negative 2 that we're plugging in here, but they look opposite when we look at the equation. So, but of course that wasn't. So we don't do any of the distribution or anything like that, no combined like terms. This, as far as what they're asking to write it in point slope form, this is the answer in point slope form. Okay. Woo. And so then we want to transform that into slope-intercept form. So now we're going to do the distribution. Now we're going to do the combining like terms and getting a y by itself. So I'm just going to write that again. So y minus 5 equals 4 times x minus 2. And I'm going to distribute the 4. So I get y minus 5 equals 4x minus 8. And I'm going to add that 5 over. So y equals 4x. So negative 8 plus 5 is negative 3. So there's my equation in slope-intercept form now. So you can see, comparing, right, slope-intercept to point slope, right? The only thing that's the same now is that the slope is, still 4. We can see that, but now we know the y-intercept rather than just this random point on the line. Okay. So there's our two equations they asked us to write. So make sure you're reading the instructions there about how you're supposed to write the equation, what form they want it in. And last form, talk about with lines. There's 3 forms. There's point slope, slope intercept, and then there's standard form. Slope intercept is probably the easiest form to graph from. Point slope is pretty easy to graph from. Standard form is generally not very easy to graph from, but it's got a different type of reason that we would use it. There's a lot of situations where it's easy to write it as standard form equation. When we talk about like if somebody bought 5 pounds of walnuts, and the walnuts cost $5 each, and then plus 3 pounds of pecans, and pecans cost however much each, and then how much is that going to be equal to, or something like that. So when you have variables that are independent of each other, kind of like that, it's standard form is usually a good way to try to relate those things. So when we're not directly given information about the points on the graph or its slope, we use this form. Okay? A, B, and C have to be integers, and the constant is always by itself on the other side of the equation. So we shouldn't be having any fractions in our answer when we're done. And then that C, that constant should always be by itself. So x and y both need to be on the left side, and then the constant needs to be on the right side. So I'm going to give us some information about the line and its slope and a point that we want it to go through, and we want to end up writing it in standard form. So it's a little tricky, but it's not generally a skill that we work a lot on in Algebra 2 or anything like that. So because they're giving me the information they're giving me, which is, i.e., the slope and then just a point, I'm going to start off in point slope form. So y minus, and so my y value of my point is 1/3, equals, and then the slope is negative 1/3, and then x minus, and then the x value of my point is 1, so x minus 1. So here I have that in point slope form. So I need to go ahead and get the distribution done. You notice in standard form there are no parentheses, so I need those parentheses to go away. So I'm going to go ahead and distribute that. So y minus 1/3 equals negative 1/3 x, and then negative 1/3 times negative 1 would be positive 1/3. And so, goal of getting x and y on the left side, and then all constants on the right side. So I need that minus 1/3 to move over to the right. I need the x to move over to the left. Add that. And so that ends up with positive 1/3 x plus y, and then here 1/3 plus 1/3 is 2/3. So we've gotten the x and the y on the same side, and we've got the constants all on the right side. So we've got that part down, but what we don't have is we don't have everything being integers, right? Which means no fractions. So looking at my denominators, I have denominator 3, 1, and 3. Right? So remember, we get rid of denominators by multiplying by them. And if I want to multiply a part of something by if I want to multiply part of a fraction by something, I have to multiply the whole fraction or whole equation by that same thing. So multiply everything by 3 to get rid of those 3's. And something we talked about, you know, in section 1.6 and other points too, how to deal with common denominators. Sorry, let me fix this stuff again. So multiplying everything by 3. So what happens when I multiply this by 3, right? 1/3 times 3 is, of course, just 1, so that'd just be 1x. And here, positive y times 3, of course, would be positive 3y. And it equals 2, and then 2/3 times 3 is just 2. So there's the equation of that line in standard form. So x and y are together on one side, the constants are on the other side, and then the coefficients and the constant are all integers. So you can see that, you know, we don't see the slope anymore. That point that we had earlier is just gone, right? It's all hidden away. So this form of the equation does not help us in graphing at all, but again, it has its purposes in other realms of math. So there would be that. So this is kind of this last parts here, or this next example, sorry, is kind of going backwards, right? If we have the line in standard form already, and you want to graph it, you know, you want to identify its slope and its y-intercept, you know, just solve for y, right? Get y by itself. So you're just looking at this. You know, we talked about those literal equations where you're trying to, you know, isolate one variable. So it's just that same idea, like how do you get y by itself, right? So kind of focus yourself on that y, say what needs to go away. You know, make sure you're using SADMAP so that, you know, I know what to get rid of first, because the, you know, this 2x is just adding to the side because it's a positive 2x, and then this negative 3 is multiplying the y, right? And so adding and subtracting are supposed to be eliminated first when we're solving. So I'm going to subtract 2x here. That would give me negative 3y, and so I'm going to put the x in front, so it's negative 2x minus 6. And now I'm going to go through and divide by negative 3 everywhere. So I suggest you do little individual divisions like that on this right side, rather than like one big division. So doing that, mathematically they're the same, but visually I think you're going to be helped out by doing little individual divisions. So divide this part by negative 3 and divide this part by negative 3. Just like we had to up here, you know, when I wanted to multiply something by 3, I had to multiply the whole equation by 3. Well, since I want to divide this by negative 3, I have to divide the whole equation by negative 3. I can't just divide this part or just this part, or just the whole equation has to be divided by negative 3. So keeping that balance. Of course, on the left side, we just get y. Here, you know, looking at the slope, so negative and negative give me a positive 2/3 x. And then looking at the y-intercept, a negative and a negative would give me positive 2. So there's my slope and y-intercept form. So identify the slope. Let's make sure you're answering the question, right? So I want to know what the slope is. Of course, that's 2/3, or 2/3. And then the y-intercept would be 0, 2. So there, I've actually answered the question. All right. Last one here that we're going to do today on this part of the video. Write the equation of the line that passes through these 2 points in slope-intercept form. Okay, so make sure you're going to think about what the answer is going to look like. You need to end up at y equals mx plus b. You know, and so in that way, you know, what do I need to have? What are the pieces I need in order to accomplish that? I need to know what the slope of the line is, and I need to know what the y-intercept of that line is. So looking at the points we have, right, can we answer either question right now? So the slope, well, 2 points will help me find the slope, but I don't know the slope right now. So is either of these points the y-intercept? So remember that we're looking at what we have. Neither one of these have an x-coordinate of 0, so neither one of these is the y-intercept. So I'm going to have to find that also. Okay. I'm going to start off by finding the slope. So I want the change in my y values over the change in my x values. So looking at my y values, how do they change? So from -3 to 5, I would have to add 8 in order to do that. And then to go from 5 to 3, I'd have to subtract 2. So my change in my y values to over my change in my x values. Right? -3 plus 8 is 5. 5 plus -2 is 3. Right? So 8, -2. Of course, that reduces down to -4 over 1, or just -4. So lots of different ways to finish this. We just kind of use something we've already talked about, which would be the point slope form. Since we have the slope and then we have points, but we only need one point to do point slope form. So I'm just going to grab one of the points. It doesn't matter which one I use. So y minus, and so my y value here is -3. So y minus -3 would be y plus 3. That's equals the slope, which is -4, times the parentheses x minus my x value, which is 5. So again, I'm not using this point here, I'm using this one here, -3 here, and the 5 goes here. So now it's in point slope form, but not what I want. I want it in slope-intercept form. And so now I'm going to use the distribution and getting y by itself. So that would get me to y plus 3 equals -4x, and that'd be plus 20. And then subtracting 3 over. So that would be y equals -4x plus 17. So again, just reiterating that neither of these points was the y-intercept, right? We can see that the -3 here, the 5 here, not in this problem at all. Okay, that's a really common mistake I see students make. They find the slope and they go, oh, -3, I'll just chuck that in there, or oh, 5, I'll just chuck that in there. And that's not okay to do. Again, there are multiple ways to go from this and having this information to getting here, but that is not an acceptable way. So I just showed you one method. If you know another method you like better, then have at it. So that's where I'm going to stop this video. Again, so what I want you guys to do, to start this assignment, is this part of it. Actually, that's not right. It should only be this. So that 3 and then 23 through 29 odd. And then later on I'll finish the video and have you guys finish the rest of that assignment and turn it all in at once. So, alright, see you guys later.